Yeah. Today we'll discuss about the demultiplexer.
Okay, sir.
Mm. So demultiplexer is just opposite of multiplexer. It have a single input, okay, single input, one input, okay, one input, and it have two power n outputs and n selection lines.
And selection.
Okay, n selection lines. Okay, depending on the selection line, any one of the input is this single input is connected to the multiple any one of the output. Okay, so input is connected to any one of the output. So we can implement the so by using demux, we can implement boolean functions. Okay, boolean functions, and we can implement combinational circuits also. We can implement the combinational circuits by using demux. Okay, so the diagram will look like this. This is a general diagram for demux. So you have one input and two for n outputs. Okay, and so this is demux. So this is 1 cross 2 power n demux. Okay. So
Yes.
n selection lines. Okay. These are the selection lines. Selection lines. And these are the inputs and the output. Wait, fine.
Fine, sir.
Okay. Suppose if you consider 1 cross 2 demux. Okay. So if it is 1 cross 2 demux, 1 cross 2 demux. So how many inputs are there? One
One.
input and two outputs. And how many selection lines? One selection
One
lines.
selection lines.
Okay. So if you see the block diagram will look like this. 1 cross 2 demux, one input and two outputs. Let us take y1 and y naught. These are the two outputs and one selection line. Okay. So one selection line and one more enable pin is also there. Okay. Enable pin is acting like a switch. Okay, when enable equal to 0, whatever may be the this is the input, whatever may be the selection line, the output will be 0. Okay, so I can draw the truth table for this.
Sure, sir.
Truth table. Enable selection line
Yeah.
and next y1 and y naught. Okay,
Okay, sir.
so when enable equal to 0, selection line is anything,
Plus,
the output is what? 0. When
sorry, sir.
enable equal to 1,
Okay.
selection line is 0. This D input is connected to Y naught. When selection line is 0, D input is connected to Y naught.
Well,
Okay, this is 0 only. And when enable equal to 1, selection line equal to 1, D input is connected to Y1. D
okay, sir.
input is connected to Y1. Okay, this is 0. Okay, so from this you can get the expression. What is the expression? Y naught equal to mm, enable S bar and D. And y1 equal to what? Enable S and D. So now you can draw the logic diagram. So this is enable pin and one more selection line. One selection line is there. This is yes. Okay. So again input is B. Okay. Enable selection line bar and D is connected to an AND gate. This is Y naught. Okay. Enable selection line yes and D is connected to Y1. Is it fine?
Fine, sir.
Okay. Yeah. Next, one cross for demux. One cross for demux. If you see demultiplexer. So it have how many inputs? One input.
One input.
This is D. Okay. And how many selection lines?
Uh,
Four. Four means what?
four.
Two square. Two square
Two
means
square.
two selection lines. And how many outputs?
Uh, four.
Four outputs. Okay. So if you see the block diagram will look like this. D input and Y naught, Y1, Y2, and Y3. 1 cross 4 DMUX. Okay. And this is S1 and S0. S1 and S0. Okay. So coming to the truth table. So enable pin and next S1 and S0 and Y0, Y1, Y2
What two? What
and
three?
Y3. So when enable pin is 0, whatever may be the S1 and S0, the output will be what? 0 only.
Zero.
When enable pin is 1, then this DMUX will be activated. When it is 0, 0, so this input is connected to which one? Y0 pin.
Why not?
Okay, remaining all are 0. Okay, and when enable pin is 1, 0, 1, this input is connected to Y1. So 0, D, 0, 0. Okay, and when enable pin is 1, 1, 0, this input is connected to Y2.
Why
So
two?
0, 0, Y2. D is connected to Y2. When enable pin is 1, this input is connected to Y3. So 1, 1, 0, 0, 0, D. Okay. So you can what is Y naught? Y naught
Why
equal
zero?
to what? Enable S1 bar, S naught bar. No?
It's not bar.
Y1 equal to enable 0, 1, S1 bar, S naught.
S not.
Y2 equal to enable S1,
S1.
S naught
S
bar.
not bar.
Y3 equal to enable
Well, S1 is SO.
S1, SO, okay, S naught, okay.
S not.
So from this, you can draw the logic circuit, okay. So how to draw the logic circuit? Take this D input, and next S1, and it is connected to inverter. This is S1 bar, S naught, and it is connected with an inverter S naught bar, okay. So here, so what is Y naught? Enable pin is also there. Enable pin is also there.
Okay.
Enable D S1 bar S naught bar
Yeah.
connected with AND gate.
And
This is Y naught. Okay. Again enable uh, S1 bar D is also there.
D
Okay. D is also there, and S naught connected with an AND gate. This is Y1. Enable
enable
D again next S1 S naught bar connected with an AND gate. This is Y2. Okay, just expand this, and next enable D and S1 and S naught connected with an AND gate Y3. This is 1 cross 4 DMUX. Is it fine?
fine, sir.
Okay. Next, you need to implement higher order DMUX with lower order DMUX. Okay. Implementation implementation of higher order higher order DMUX using lower order DMUX. Okay. How to implement means, first there are steps are there. Step 1, calculate the number of DMUX required by dividing higher order with lower order. Okay, calculate the number of demux required by dividing higher order with lower order lower order demux. Okay, step 2 continue till we get 1. Continue till we get 1. Okay, add all the number of demux and connect. Step 3, add all the number of demux and connect. Okay, so I want to implement 1 cross 4 demux using 1 cross 2 demux. How to implement? First, what you need to do? That means 4 by 2. What you will get?
2.
Quotient 2. This
2.
will come in the second stage. Okay. Again 2 by 2. What is the quotient? 1.
1.
This will come in the first stage. Okay. So that means so in the first stage you are connecting 1 demux. Okay. This is D input and enable pin is common for this mux and this demux and other demux. Other demux. Okay. This is 1 cross 2 demux. 1 cross 2 demux. One input and two outputs. Let us take the outputs are y0 and y1. Again, this is given as a data pin to this demux. Okay. Again, this is given as a data pin to this demux. Okay. Data pin to this demux. And this is first stage and this is second stage. And one more selection line is there, no? So for this selection line, you are using S1, okay, and for this you are using uh, that is selection line. You are using S0, okay. Common enable pin is for both the demarks. Here common enable pin is there. So this is enable pin, and this is also enable pin. This is connected uh, to this one, common enable pin. So
Okay.
like this, you will implement 1 cross 4 demux by using 1 cross 2 demux. Is it fine?
Fine, sir.
Okay. Suppose one more implementation is there. So how to implement means here this is 1 cross 2 demux, and this is one more 1 cross 2 demux. This is one more 1 cross 2 demux. Here what you are doing means data line, whatever the data input is there, D input. This is common for this demux and this demux. Okay. One selection line S0 is there, no? S0. Uh, you are giving common for this one and this one. Okay. What is that S0? Okay. One more selection line is there. Okay. So one more selection line you are giving through the inverter. Here, let us take S1 is there. It is giving through the inverter. Okay. Through the inverter, it is given to enable pin. And here, this is given to the enable pin. Okay. This is given to the enable pin. Okay. So, how you can analyze means here, how many outputs Y0, Y1, Y2, Y3.
Y3.
Okay. So y naught, y1, y2, y3. Okay. So we already see in the truth table, no? So that is s1, s naught, s naught, and y naught, y1, y2, y3. Okay. So that means 0, 0, 0, 1, 1, 0, 1, 1.
Why
Okay.
not?
So when y naught is 0, 0, y naught is d. Okay. Remaining all are zeros. And 0, 1 means y1 is d. Remaining all are zeros. And 1, 0, y3, y2 is d. Remaining all are zeros. 1, 1, y3 is d. Okay. Just if you divide, see here. When if you see, this is given to when s not equal to 0. One second. Oh, s not and s1, no? S not. So s not and s1 means, yeah. S1 is given through this one, no? So that means when s1 equal to 0, this becomes what? 1. This becomes 0. So during this case, first case, you are getting this mux will be, this demux will be active, and this demux will be deactive.
Deactive.
Okay. So that means you are getting the output from where to where? Y naught to y1.
Why one?
Is it fine?
Fine, sir.
Suppose, okay, suppose like when you are getting, when s1 equal to 1. Okay, this case, this is first case. Second case, you see, when s1 equal to 1, this becomes 0 and this becomes 1. Now, which will be active? This will be
This
deactive
will be deactive.
and this will be active. And you are getting the output from outputs y2 and y1. So now which one will select? S naught will select. So suppose here S naught equal to 0. So that means S naught equal to 0. This D is connected to Y naught. If S naught equal to 1, D is connected to Y1, depending on this S naught. Here also, when S naught equal to this is commonly connected, no? When S naught equal to 0, D is connected to Y2, and when S naught equal to 1, D is connected to Y3. So we are getting y2 and y3. See here, depending on this one, we are getting D is connected to y2 and y3. Here, when depending on S naught and y naught, D is connected to y naught and y1. Is it fine? Do you understood?
Fine, sir.
Okay. And next, if you see implementation of higher order demux, higher order demux, implementation of higher order demux. Let us take. I want to implement. Uh, 1 cross 8 demux using 1 cross 4 demux. Okay. How to implement? First, you need to divide 8 by 4. What you are
4,
getting? 2, no?
2.
2. So that means here, this is come in second stage. In first stage, 2 by 2. So that means first stage, you are using, you can use inverter or you can use 1 cross 2 demux. You can use 1 cross 2 demux. Okay. So how to design means first stage you have 1 cross 2 demux, and this is D input, and two outputs are there. This output is given to, so in the second stage you have two 1 cross 4 demux. Okay. So this is 1 cross 4 demux and 1 cross 4 demux. This is 1 cross 4 demux. Okay. How many outputs are there? Four outputs are there. Y naught, Y1, Y2, Y3, Y4, Y5,
5,
Y6,
6.
and
Why, sir?
Y7. Okay. So this is acting as a data pin for this demux. Okay, one more input output is acting as a data pin for this demux. Okay, and enable pin is common for this demux and this demux and this demux and this demux. Enable pin is common only. Enable pin is common. Yeah, this is enable pin. And here you are giving S2 and S1 and S0 are common for these two demux. This is S1 and let us take this is S0. Like this you can implement. Okay.
Okay, sir.
Okay. One more implementation is how to implement so by inverter. So that means in the second stage you are using two 1x4 demux. This is also 1x4 demux. D input is common. Let us take this is D input. D input is common. This is D in. D in is common for this demux and this demux. Okay, demux. And let us take selection lines. This is S1 and S1 common. S0, S0 common selection lines. And these selection lines are given to let us take these are given to BC. BC and A is there, no, one more selection line. Let us take A. This is given to the enable pin and oh sorry, not this one. No, from here it will come. Uh, from where means here it will come. Enable pin. Okay. Now if you observe the truth table, so that means A, B, C. Okay. So and how many outputs? 1, 2, 3,
One,
4.
two, three, four.
1, 2, 3, 4. 8 are there. Y0, Y1, Y2, Y3,
Y3,
Y4, Y5,
Y5,
Y6, Y7.
Y7.
Okay. So let us take that means Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. Okay. So 0, 0, 0. Three inputs are there. How many possible combinations?
Uh, nine,
Eight possible
eight
combinations.
possible.
Two cube. Two cube means eight. 2 cube means 8 possible combinations. Here when it is 0, 0, 0, D is connected to Y naught. 0, 0, 1, D is connected to Y1. 0, 1, 0, D is connected to Y2. 0, 1, 1, D is connected to Y3. Okay.
Y3.
Just you divide. This one you divide. Again 1, 0, 0 is D is connected to remaining all are 0 only. Now I'm not writing. Again 101 means D is connected to Wi-Fi. 110 means D is connected to Y6. 111 is D is connected to Y7. Okay.
Y7.
Now you see. So that means A will decide either you need to get Y0 to Y3 or Y4 to Y6. See here. When A equal to 0. Okay.
Yeah.
When A equal to 0. A equal to 0. Here you are getting 1. Here you are getting 0. Which mux will be active? This will be active and this will be deactive, no? So you are getting the output from where to where? Y0 to Y7. So this case. Okay. So which one
Okay.
will decide either Y0 to Y3? That means these BC will decide. When it is 0, 0, D input is connected to Y0. 0, 1, D input is connected to Y1. 1, 0, D input is connected to Y2. 1, 1, D input is connected to Y3. Is it fine? Do you understood?
Understood, sir.
Okay. Next, if you see, when it is 1, this becomes 0 and this becomes 1. Okay. Second case, this will be not deactive, and this will be active. Okay, so during this state, so that means you are getting the output from Y4 to Y7. So D input is connected to Y4 depending on the selection line, and D input is connected to Y5, D input is connected to Y6, and D input is connected to Y7 depending on these lines, AB lines. Okay, okay.
Okay, sir.
Next, where you are using this application of DMUX, application of DMUX, application of DMUX. If you see, uh, so here, suppose single source is there. Single source means, let us take your computer, desktop, or laptop. Okay, and you have a selector, not selector. Other name for demultiplexer is distributor. Other name for this DMUX is distributor. Okay, so here you are using distributor. So distributor, you have that means this is DMUX. This is connected to. So here for the laptop or desktop, you have like uh, some peripherals are there. So that means from this peripherals you are connecting as a input. Okay, so two selection lines. This is a 1 cross 4 DMUX. Okay, so here four output lines are there. So I want to like these are the selection lines. So that means multiple destinations are there. Multiple destinations means you can have the so you can have the printer, black and white printer. Okay, black and white printer, or you can have fax machine. Okay, fax machine, or you can have color inkjet printer, color inkjet printer. Okay, and next you have pen plotter. Okay, so that means these all are connected to these outputs. Okay, that means here depending on the selection line, when it is 0 0, which is connected, black and white printer is connected. When it is 0 1, fax machine is connected. When it is 1 0, color inkjet printer is connected. And when it is 1 1, pen plotter is connected. Is it fine?
Fine, sir.
Okay, so this is about the DMUX. Okay,